This video is going to cover how we solve systems of equations algebraically. This is review, so we're doing this as a video so that you are able to watch this at a pace that works for you. So you should have this foldable set of notes that are it's going to go in your notebook. The first type of system that we're going to look at is the type that you're used to seeing, an independent system. This is a system that has intersecting lines. And if you have a system with intersecting lines, there is one solution. And that solution is the point XY where those two lines intersect. Okay, so a lot of times you're trying to find that one intersection point. We're going to take a look at what it looks like when we find this point algebraically. So what I'd like you to do is flip open this flap. And on the left-hand side, on top of the flap, we're going to write substitution. The examples that we do on the left-hand side are going to be solved using a method called substitution. So my first system that I'm going to solve is x equals 1 plus 8y. So that's my first line. And my second line is negative 3x minus 6y equals negative 3. Substitution is really good to use if you have a variable that is isolated. So up here in my top equation, it tells me x is equal to all this stuff that I circled. So what I'm going to do is take all that stuff x is equal to, and I'm going to go to my bottom equation, and I'm going to replace x with what is circled. So instead of negative 3 times x, I'm going to leave a space. I'm going to copy the rest of the equation down. And in that space, I'm going to put the 1 plus 8y. And now I have a single equation with only one variable that I can solve. I'll distribute first, so I'll get negative 3 minus 24y minus 6y equals negative 3. I'd like to clean up the left-hand side by combining my like terms. And now I can go ahead and work on getting y alone. So I'll add 3 to both sides. That's going to give me negative 30y equals 0. And at this point, a lot of people are like, well, wait a minute, that's not solvable. But it is. 0 is just a number. Remember, between the negative 30 and the y is multiplication. So to get rid of the negative 30, I'm going to divide both sides by negative 30. And I get that y is equal to 0. So that's the first part of my solution. But remember, a solution to a system is an x and a y. So now that I know y is 0, I can go back up to either original equation and plug that in. I'm going to plug it into the top equation because that one is a little bit simpler. So instead of 8 times y, I'm going to substitute in what I found y was equal to. And I get that x is equal to 1. So my solution would be the point 1, 0. Again, that's my x value followed by my y value. So if I were to graph these two lines, they would cross at the point 1, 0. On the right-hand flap, we're going to go ahead and write at the top elimination. So examples on the right hand are going to be solved with elimination. So here's my system. Negative 7x minus 2y equals 0. And 14x plus 7, wait, is it plus? Yeah, plus 7y equals 0. When everything is lined up, I have my X's, my Y's, my equal signs, my numbers. It could be lined up in a different order, but when everything is lined up, elimination is good to use. What I want to do with elimination is I want to get my coefficients to be the same, but with opposite signs. So I can either eliminate X or Y. In this case, I'm going to eliminate X because I know I can make a 7 into a 14 by multiplying by 2. And the X in the top is already negative. So I have a few things going for me here. It's really important that you multiply everything by 2. So this becomes negative 14x minus 4y equals 0 because 2 times 0 is 0. I'm going to carry my bottom equation over. And now I can go ahead and add these together. When I do that, negative 14x plus 14x is 0. Negative 4y plus 7y is 3y. And 0 plus 0 is 0. And now I can go ahead and divide both sides by 3. And I find that my y coordinate is 0. I still need to get my X coordinate, so I can plug it into either of my original equations. I'm going to use the bottom one. I solved for Y, so I'm going to leave a blank where Y is and replace it with 0. So that becomes 14x plus 0, which is just 14x. And then I'm going to divide both sides by 14, and I get X equals 0. So these two lines intersect at 0, 0. And that means if I was looking at a graph, that those two lines intersect at the origin. Okay, the next type of system that we could see is what's called a dependent system. And this is when you have coinciding lines. So one line is directly on top of the other. So if I wanted to know, like when X equals 1, 2, 3, is that a point of intersection? Well, yes. What about when X is 6? Is that a point of intersection? Yes. What about when X is negative 6? Yes, that's a point of intersection. So when we have a dependent system with coinciding lines, our solution, there's infinite solutions. The other way that you'll see that written is if you draw a little 11 and then draw a capital R through it, that means all real numbers. So if you go to any X value, so if I come out here to 10 and I scroll up to my lines, they're going to intersect when X is 10. If I go to 1 and scroll up to my lines, they're going to intersect there. This is different from what we saw with intersecting lines. If I went to 2, for example, and I scrolled up to my lines, they do not intersect when X equals 2. If I go here to negative 2, again, they don't intersect when X is negative 2. They intersect here when X is, I don't know what that number is, but so again, it's different. These lines lie on top of each other. They intersect everywhere. So let's take a look at what this looks like algebraically, because it looks a little different. We're going to start on the left side, the substitution side. So let's say my equation is negative 3x plus 12y equals 9. That's a line because my x and my y have a degree of 1. And then let's say my second equation is 4y minus 3 equals x. I know that substitution is good to use here because x is by itself in my bottom equation. So I'm going to take all that stuff, and in my top equation, I'm going to replace x with what it's equal to, which would be 4y minus 3. So now I can distribute. I want to clean up this left-hand side. Negative 12y plus 12y is gone. It's 0. So I end up with just 9 on the left and 9 on the right. This statement is always true. 9 equals 9. So when all your variables cancel, and you are left with a true statement. That's how you know that your answer is all real numbers. And you want to picture it graphically. That means those two lines lie right on top of each other and they intersect everywhere. So with substitution, your variables drop out and you end up with a true statement. Let's see what happens with elimination. So on the right-hand side, I want you to go ahead and write this. Negative 16x equals 12 plus 20y. And negative 8x equals 6 plus 10y. So again, it looks a little bit different, but my x's are lined up, my equals are lined up, my numbers and my y's are all lined up. So I want to make something eliminate. So I notice I've got a positive 20y. What I'd like to do is make the bottom a negative 20y. So I'm going to multiply this whole equation by negative 2. Top equation does not change, so I'm going to carry it over. And my bottom equation, when I multiply everything by negative 2, I get 16x equals negative 12 minus 20y. And now I can add these equations together. Well, negative 16x plus 16x is 0. Negative 12 and negative 20 and 20 also gives me 0. So all my variables dropped out. I ended up with a true statement. I know that these lines intersect everywhere. So they're one line directly on top of the other. They are the same line. Okay, one last type. This is an inconsistent system. This is when we have parallel lines. And in this case, parallel lines never intersect. So this is a case where you have no solution. The other symbol you might see for this is a 0 with a slash through it, or you might see what's called the empty set. Okay, but the big thing is we have parallel lines, it's no solution. So on the left-hand side, let's go ahead and see what this looks like algebraically with substitution. So negative 6x minus 3y equals negative 2. And y equals negative 2x minus 3. Again, I've got y isolated in the bottom. So I'm going to take all that stuff y is equal to, and I'm going to replace y with it in the top. So again, if this variable is y equals, we're going to plug this stuff in for y. When it was x equals, like this, we replaced x with what was circled. So just pay careful attention to that. So my new top equation is going to be negative 6x minus 3. And then I'm going to fill in those parentheses with what y is equal to. I've got to distribute. Don't forget a negative times a negative is a positive. These cancel and I end up with 9 equals negative 2. So just like with the not parallel lines, the coinciding lines, all of my variables dropped out, but I ended up with something that was false. So all variables cancel. And final statement is false. That's what tells you that you have parallel lines. They never intersect. And so there's no solution. Those two lines are parallel. Okay, so that's what it looks like substitution wise. Here's what it would look like elimination wise. So let's say I had 2x plus 14y equals 4. And then x plus 7y equals 7. I'd like to eliminate my x's, so I'm going to multiply my bottom equation by -2. The top equation stays the same. This bottom equation will become -2x minus 14y equals -14. I can go ahead and add these together. These all cancel, so I get 0 equals -10. All my variables dropped out. It's a false statement. So I know that this system has no solution, which means if I were to graph those lines, those are parallel lines. They never cross. So what did we look at? We looked at 3 different types of systems. Intersecting lines, we looked at where we get one solution. It's an X and a Y coordinate. We saw how it would look if you solved the system this way using substitution and elimination. Again, your answer is being written as an X and a Y coordinate. We also looked at coinciding lines or dependent solutions. This is where one line is right on top of the other, and you have infinite solutions or all real numbers. We looked at what it looks like with substitution. Remember, all your variables drop out and you get something true. Or with elimination, all your variables drop out. And again, you're left with something true. That tells you your solution is all real numbers. Those two lines are the same line. They intersect everywhere. And then the last type was an inconsistent system where we have parallel lines which never intersect. And again, all the variables drop out, but the final statement is false. So that tells me I have parallel lines and no solution. Okay, that's it for this video. There's some practice that I need you to work on independently. Again, this is review. So hopefully this video provided you or reminded you of the steps for solving systems algebraically. And you can start working on some of the practice.